Hello, everyone. My name is Blairta, and I'm with the Gitcoin team. Thank you so much for joining the LUKSO Standards Proposal workshop. Today is the second part of the two-part series of workshops where you will continue to learn about the new smart contract standards on LUKSO. And with us today, we have Jean, Yaman, and Fabian will be joining us a little later. Just a few things before we get started. First, this session is being recorded, and you can always rewatch it on our Gitcoin Media channel on YouTube under the LUKSO Build-Up playlist. Feel free to post any questions you have in the Q&A section, and we'll make sure to answer in the end. It definitely helps if you put them in the Q&A and not in the messages, just to make sure we don't miss any. And last, please do say hello. Let us know where you're watching from. We would love to get to know all of you. And with that, I will hand it over to the team to get started.
Thanks, Blairta. Hello, everyone. Thanks for joining the LUKSO Standard Proposal Workshop Part 2. Just to give you a quick introduction about myself. So my name is Yaman. I'm a smart contract engineer. We also have Jean Cavalera. Jean, do you want to say hi?
Yeah, hi, everyone. Welcome back again for this Part 2.
Cool. So yesterday in the workshop part 1, we talked about the problem of externally owned account and identity. And we also talked about the problem of smart contract interaction. And we saw how we can solve all of these problems with what we call universal profile that are smart contract based account. And we also saw how we can extend the functionality of a universal profile using what we call the LSP 6 key manager. And all of these standards will fall under a category which is almost universal profile. And today we are going to go to a different topic, and it's the digital asset and NFT 2.0. So we call them NFT 2.0 because they are like more up-to-date standard. They have more features that we're going to explain in this presentation. And today we are going to talk specially about the LSP4, LSP7, 8, LSP5 and 12, and the LSP9 vault and the received vault. So I will leave it to Jean to start with the background of tokens and NFT. Jean, it's all yours.
Okay, thanks a lot, Yaman, for this introduction. So before we get started into this second part to talk about the digital assets and what type of digital assets we can create with using the LUKSO standard proposal, we first need to get a bit of a background and look at the current state of what kind of standard we use to do the same thing at the moment. So if you look in the landscape at the moment, we use standards like ERC20 721, or like ERC 777, and we mostly use them to represent either tokens, NFTs, fungible or non-fungible. But in the end, what we end up having is that we represent this form of digital assets mainly in the form of static assets. These are mainly static assets that reside on the blockchain, and they are tied to ownership. It's a form of ownership that is tied to an address. And the problem with this current asset, because they are mainly static, is mainly that they lack of metadata. So let's take an example of an ERC20 token. If we look at the possibility of what kind of information we can add to an ERC20 token, we can add things like the name of a token, the symbol. This is pretty basic. We all know how to do that when we deploy the contract. But we cannot really add things like who created this token, or we cannot really know why this token exists and what's the exact purpose of this token, and which community, for instance, is behind it. It's not something really that we can write on-chain inside the token contract. So there is not such place to store really the information because there is really these three basic functions in the interface. and it's with really basic state variables of a token contract. And some of you might tell me, like on ERC-721, there is this function called token URI, but it's mainly the only thing that links that really in an NFT we can add more custom information. And really, apart from that, we cannot really add much more apart from this token URI. And if we remember, for those who were at the first workshop yesterday, we learned two main types of standards in LUKSO. We saw that there were we talked about some interface standards, and we saw that there were metadata standards. So at LUKSO, when you try to build digital assets or universal profile or any form of special contracts using the LSP standards, you will see that there is these two main categories of standards that you can use to build your own contract. There are the interface standards. These are the standard set of functions. So, for instance, something like ERC-1271, or we have metadata, and we have metadata standards, which is really specific to it relates to LSP2. Is the default data key that we can find in the contract storage that we can use to standardize some default entry into the contract storage. So we can use these. We can use these interface standards to create a standard contract, to know how to interact with them, and so this enables us to be interoperable. And we have these metadata standard really that enable us to create some form of metadata standard like a universal profile. So we saw the universal profile is a contract that has this predefined set of data keys in its storage. And if you think about it, if we have this metadata standard and we can add default metadata to any ERC-725Y contract, why yesterday we saw that we could do that with a blockchain-based account, but why can't we do that with something else then? How about if we add default metadata to something else than just a universal profile? So for instance, a token, what we will see, we call LSP7, or an NFT LSP8. What happens if we add this default metadata key in a token or an NFT contract? So if we combine basically an interface and a metadata standard using the LSP as building blocks, we can create a new form of digital asset. And we're going to see that first with this metadata in token and NFTs, what we encompass as digital asset at LUKSO. So the first standard that you can see from this previous picture is what we call LSP4. And LSP4, why we have a metadata standard for digital asset? It's simply because as we said, we have this limitation on how much we can really customize tokens and NFT. So the motivation of this standard is really that we want to be able to customize as much as we can a token or an NFT. We want to add very custom and specific information into the contract storage, and information that really relates to the token and that makes it really unique and personalized. We want to be able to do things like adding the creator of the tokens, so that then the creators can, if they created the token, they can reference themselves, and they can, as a result, use this reference in the token contract storage to share credit or obtain royalties if it's an NFT. Or we can then add more custom information like the purpose of the token, the community behind it. So the problem that we are really trying to solve when we use LSP4 is that we're trying to find a standard way to describe an asset, but not only just to describe it, but to make it in a way that the digital asset can be as flexible and as extensible as possible. we want to attach much more than just the information like the name, the symbol, and a token URI. And so how we do that? We do that with ERC725Y, using ERC725Y as the underlying contract, as the underlying contract storage for the token or the NFT contract. And then we use this standard metadata key that we saw yesterday from LSP2. And thanks to that, we can add as much metadata, as many metadata as we want. So the first default data key that is part of LSP4 standard is the supported standard LSP4 digital asset. And this data key, it's the same as what we saw yesterday. It's an entry that enables us to verify that the token of NFT is an LSP token. It's a token that we can add as much metadata as we want. If we have this entry, we can have a guarantee that this is the case, that this is a token on NFT that implements like a very flexible storage. So then we move from just having state variable like the name of a symbol to data keys like this one. So we, instead of standardizing the entry and the description of a token or of an NFT contract through state variable, we standardize it through the metadata key. So the token name becomes an entry in the ERC725Y storage called LSP4 token name, and same thing for the symbol. And if you want to retrieve the name of a token, you just get into the ERC725Y storage, and you use this data key. And so, as you might think, okay, but if we can add read and write data into the contract, we can maybe in the future edit the token name. And it's not something that we want. We want to, the standard behavior is that when we deploy a token contract, we set the name and the symbol straight after deployment, and this cannot be deleted. So we have covered this case in our implementation, and this is a code snippet for the LSP4 digital asset metadata contract. We basically enable the token owner, the owner of the token contract, to set any metadata apart from the token name and the token symbol, as you can see here from the code snippet. So then what we want to do, as we say, we want to be able to attach as more custom information to the token contract. And how we can do that? We can do that through this data key. We can add as many entry in the ERC725Y storage as we want, but what we say is that the standard way to get the description of the asset, like we did yesterday to get the details of a universal profile, it's by retrieving this data key in the contract storage. So yesterday we saw if we want to see the details of a universal profile, we go through the LSP3 profile data key in the contract storage. For a token, the same principle applies, but we just use LSP4 metadata. And in this entry, it will reference to a JSON file, and we can add things like the description, the image, or we can link assets file, and we can add as many custom fields as we want in the JSON file. So let's look at a practical example from the universalprofile.cloud website. This is a digital asset created by the Dematerialized, and it's an NFT. It's a very cool and unique digital collectible called the Demat Mono. And these digital assets, all the information that you can see here on the screen is fetched in the same way as a universal profile from its JSON file. So this JSON file, which can be stored, as Fabian was explaining yesterday, into a decentralized file storage, or like a cloud storage, or like a private server. We can reference all this data, and we can add things like the description of the asset, some image, same thing. We can add custom size to enable interfaces to retrieve the most optimized size for display. And we can add more things. We can also add things like the icon. and we can add as even more specific information. This is another example of another digital asset from the same company. It's called this one is called Artifact, and you can basically reference things that like an audio file, and you can add this as the asset, the hash of the asset file, the media file. And what we can also do on top of this custom field, on top of really describing the digital asset, is that we can reference with LSP4 the creator of the digital asset. So there is another metadata key in LSP4 that enables us to list who created this digital asset. And this is the whole schema for LSP4. So you can see all the basically the fields that we have just covered. And if you want to look at an LSP7 token or an LSP8 NFT, you can get all of the basic information of the digital asset by querying the contract storage and looking at these entries. So here's an example of how we can use LSP4 to really customize and digital asset. We can use LSP4 to add more features and description to the token. We can use the standard to make an NFT collection even more unique by really describing with a lot of details in the JSON file. We can describe the community behind this digital asset. And we can then, as a result, because we have this flexible, because all the data is inside the contract storage, we can enable digital assets to evolve over time because of the course of the history of the asset. We can add more entry into the contract storage. We can remove entry. We can update the contract storage. So we can literally make the digital assets evolve over time. And another thing that we can do using this, using LSP4, is that we can do some automation as well in the contract. We can automate changes in the digital assets. So, for instance, if a certain event happen in a certain environment, like a digital marketplace, or if an asset is owned by a universal profile, we can trigger automation, as we saw yesterday, through the universal receiver delegate. And the universal receiver delegate could, for instance, edit the asset of edit the data of the digital asset. And we can then also list the assets of we can list the creator of this asset, so that then can also receive royalties or commissions when these digital assets are sold on marketplaces. So, for instance, you can think of a scenario where you have the asset which is displayed in a marketplace, in a digital marketplace. When the token of the NFT is sold, it's gonna trigger a call to the universal receiver function, and then we can. And if this contract is, for instance, a universal profile, if the owner of the asset is a universal profile, or who is transferring is a universal profile, then we can trigger all this automation. So now I'm gonna leave it to Yamen to go over the problem of tokens and NFTs.
Thanks, John, for this great explanation of the lack of metadata problem. So the problem that John explained is not the only problem that we have with token and NFT. We have few other problems, and one of them is sending tokens to the wrong address. So while we're transferring some tokens, we could do some mistakes. So here we have an example of two addresses. You can see that these two addresses are almost the same, but the first one have a 6 and the second one instead have a 9. So if you're transferring a token and you made like a mistake like this, it's a really big problem, because the first one could be a Uniswap ETH USDC pool, and the second one could be an external owned account that could be not controlled by anyone. So if you send token to the second address instead of the first one, all of your tokens are lost. And it's a common problem that we have. So if we go on Google and we type send token to wrong, we will see that almost all people, a big amount of people has done this mistake, and they're searching for a solution. And currently there is no solution to this. So if you send your NFT to a wrong wallet or a wrong address, it will be lost. So we need to think how we should mitigate this, especially because in the blockchain space, we have non-technical people. Like, not all people know how to transfer an ERC20 token. For us, it may be like easy, but for other people, it may be hard. And another scenario other than like a mistake in the address by manually typing it, we can have a wrong address when we select, when we have a drop down in MetaMask and we select the wrong address. We can also send tokens to a different address if we misread the documentation of a protocol and we send these tokens to the address of the testnet contract instead of the mainnet. And it can happen, especially in DeFi, when you send the tokens to a wrong liquidity pool. So transactions are not reversible in nature on the blockchain, so we cannot undo the transaction, but transaction can be revertible. So if we notice that we're doing something wrong, or if we noticed, like if the contract noticed that we're doing something wrong, it can revert. So our objective is to prevent tokens from being lost or stuck in a contract. And this is what we're aiming to. This is what we implement in LSP7 digital asset and LSP8 identifiable digital asset. We have a solution to this problem. But just to give you an overview about LSP7 and LSP8, LSP7 is a new standard for the fungible tokens. So it will replace ERC20. And LSP8 is an NFT standard, so it will replace ERC721 or 1155. So these two standards have more features than the current standard that we currently use, and they are more flexible and more secure. So we're gonna see how we can solve the problem of sending the tokens to uncontrolled addresses. So this is the transfer function. The first parameter is the address of the sender. The second parameter is the address of the recipient. Here we specify the amount of the token we want to send, if it's a fungible token. And here we can send any arbitrary data. But here we added a new parameter, which is the force parameter, and it's a Boolean. So this Boolean could be true or false. If we have this Boolean as false, when we're sending tokens, it will the token will only be sent to smart contracts such as the universal profile and the LSP0 ERC725 account. And if we send these tokens to externally owned accounts that are controlled by private key, the transaction will not go through and it will revert. And it's not just for externally owned accounts, it's also for smart contracts. So not all the smart contracts, some type of smart contract, because we have also a type of smart contract that doesn't know how to handle these tokens. So you could send a token to a smart contract, and this smart contract doesn't have a logic inside of it to retransfer this token to someone else. So this will make the token stuck in the contract. So we need a way, we need a sign to know if the smart contract have a logic to handle this token transfer or to retransfer these tokens. And a good sign to know if a smart contract know how to handle these tokens is the universal receiver. So here, if we send a token to the universal profile, it will be accepted because the universal profile implement a universal receiver. And in this way, not only smart contract-based account or universal profile will be able to receive tokens. it will be any smart contract that implement this function will be able to receive the token. So if we have, for example, like a decentralized exchange that implement the universal receiver, it's not a smart contract based account, it's not a universal profile, it's just a token contract representing a decentralized exchange. And by implementing the universal receiver, it can be notified about anything. At the same time, it will be able to receive tokens. So the default option is to have the force parameter as false. In this way, we can restrict sending tokens to externally owned accounts, because in the LUKSO ecosystem, we will use mainly the externally owned account to control the smart contract-based account and to control the universal profile and not to hold assets. Holding the assets should be done on the universal profile. And also with the default option of the force parameter as false, we will also restrict sending the token to a smart contract that doesn't implement LSP1 universal receiver. But if we set the force parameter to true, we will be able to send the token to an externally owned account or even a smart contract that doesn't implement the universal receiver. But we should be aware, if we make the force parameter as true, any externally owned account will be able to receive the tokens. So even if it's not controlled. And I will give an example for this. So let's say we want to send a token to Bob, which is our, and Bob is our friend, and we set the force parameter to false. So we go with what we advise for. So we should always set the force parameter to false if we're sending to a universal profile. So if we set this as false and we want to send the token to Bob, we will take his address. But if we made a mistake and we took the wrong address, and as human we always made mistakes, so we take this address and we think that this address is supposed to be the address of Bob, but this is the address of an externally owned account that is controlled by a private key. And now when the token contract will see that this address is not the address of a universal profile, it's an externally owned account, it will directly revert by saying this, that you have set the force parameter as false, but you're sending to an externally owned account or a smart contract that does not implement the universal receiver. So that's why we should implement that's why we should put the force parameter as false. But if we have set it to true, then we will take this address and we will think this address is the address of Bob, and we will do the transfer, and the transfer will be successful. In this way, we lost control over the tokens because now they are locked inside this address. So that's why we should keep the force parameter as false if we're sending to universal profiles. And if we want to force this transfer to a specific smart contract that does not implement LSP1 or to an externally owned account, we should set it to true. So now we will go to another problem. I will give you just a second so you can take a break and process all of the things that I said. Okay, so now we're gonna go to another problem of token NFT, and it's something that I explained yesterday. So, and it's about the token NFT contract design. So you as a sender, if you want to transfer a token, an ERC20 token, the token contract will just decrease your balance, and it will increase the balance of the recipient. And it's the same for ERC721. If you want to do a transfer, it will just remove the ownership of this specific ID from you and pass it to the recipient. And the recipient will stay outside this interaction because it's an EOA and it can't be informed about this transfer. So that's why we have a solution to this problem with token hooks. So the LSP7 token contract, when we do a transfer, when we call the transfer function, as well as updating the balances, the token contract will inform the sender about the transfer, and it will inform the recipient. So the informing should, and it's the same for LSP8, it will inform the sender and the recipient. But informing the sender and the recipient should be done through the universal receiver function. So now both sender and recipient are notified about the transfer, and now they can handle it with a specific logic inside the universal receiver delegates. And now I will leave it to Jean to explain you a specific feature related to LSP7, and it's not in LSP8. Jean, it's all over yours.
Okay, thanks, Yamen, for explaining about this new bull feature and the forced transfer. So as Yamen explained, we saw that one of the new feature in the LSP digital assets, whether it's LSP7 or 8, we have this safety feature about transferring. And we have another extra feature in the digital asset, so the fungible version of the token on LUKSO. It's what we call the ability to make the token either divisible or not. And the reason for this is very simple. It's that you can have cases where you want to create a token, but you don't want to make it fractional, meaning that you don't want to be able to transfer a portion of a token. So fractional in the sense, if I send you fractional, meaning I could send you $1 or one DAI or half of a DAI or 1/4 of a DAI. Here you can have the scenario where you want to represent the token, but you don't want to be able to for users to transfer one part of it. It's either you transfer the whole token or you don't transfer the token. But these tokens can represent all the same thing. They are not necessarily unique. So all the tokens, they have all the same utility if you exchange one token with another. So like, let's imagine if Yamen has one token, one of these tokens, and I do have one of these tokens. If we exchange them between each other, it's exactly the same. They're not unique. They have all the same utility. And some example of scenarios is, for a good example is digital ticketing. You can create digital tickets, whether for example, an event. So to be able to attend to an event, all the tickets are the same. They are interchangeable. If Yamen and me, we have, for instance, an entry ticket to a big DEFCON event. Whether we swap it between each other, the ticket with Yamen, it's the same. We'll both be able to access the event. It has the same utility. But you cannot rip off a ticket in 2 or in 4 and give pieces between each other. It's not something that is possible. So you have this feature in LSP7 to make the token, when you deploy it, either divisible or non-divisible. What will happen is very simple, is that when you deploy the token and you specify divisible to true, it will set 16 decimal places, so the equivalent of a decimals function in ERC20. And if you set divisible to false, it will set the decimal places to 0. So it's not possible to fraction it. Another example is, for instance, of divisible and non-divisible is for video games where you want to manage in-game currency. If you want to have a video game, you want to create a digital currency, a crypto token for the game, you want to be able to transfer one part of a token, or for community token, for the same principle. But if you, as we say, for like tickets, for instance, for digital tickets, you don't want to be able to split them in fractions. Then there's another problem around, I'm going to go for another problem around NFT and metadata related to NFT. So after this problem of after this feature of divisibility, we now have this feature around metadata. And there is currently a problem in NFTs, which is quite big. Is that if you think about it, the whole metadata for an NFT is really stored in an external resource on the web. It's a reference which is referenced by this token URI. And you have NFT that are out there that are sold, and the JSON URL is linked to a Google Drive. But think about it. What happens if it's a server? What happens if a server get compromised, hacked, or if the person, or really simply, if a person who put the information of the NFT in this Google Drive, how about if the person just delete the folder, the D folder of a Google Drive? What happened then for the NFT? It really lose its uniqueness. So the problem of NFT, we try to tackle it with LSP8, identifiable digital asset. And this new standard, what it really emphasizes on, is really the problem of metadata. It's that if you want to represent NFT, you have to reference to the metadata by the data itself. You have to do a data reference, which we call a hash reference, and not a resource reference. Because as we say, linking an NFT to a URL, it's very bad. Like, how about if a server that stores the metadata goes down? Or how about, how do you know who can change the actual metadata? It's something that you can leave, like off-chain, you cannot really know that. And how about if over time, one big question also that could be quite interesting to know is that how about if the metadata of NFT is in this JSON file, and how about if someone at some point edit the JSON file? How do you know that the NFT has been altered? You would not even know. You would hold an NFT that could have been altered without even knowing. And so the idea behind LSP8 is to represent an NFT as, first of all, more than just a token ID, with something that has a more flexible and that has a metadata that can be represented in a different way. So not just a token ID linked to a JSON file. We're going to see with a different type of NFTs we can do with LSP8. But we want also to be able to counter this problem of it's not that we don't want to allow the NFT to evolve, to have its metadata updated. It's something that can be possible if you represent an NFT in a video game, for instance, like a weapon as an NFT. Some people might know that sometimes you can upgrade the weapon in the video game. You can alter this feature. So you want to be able to do that, to represent the digital asset as totally unique. There is one of a kind, but you can also want to give it some ability to evolve and alter over time. So the problem is not necessarily about not being able to alter it, but if you want to alter it, you have to be able also to know when and by whom it has been altered. And so how LSP does that? It's by using hash reference to the metadata of NFT, and we're going to see we can also describe the metadata of NFT. We can describe the NFT collection and each NFT individually. And how we do that? We also do that by enabling a singular NFT to be its own ERC75Y contract. So how we do that? With LSP8 we have this standard metadata key, and this standard metadata key it's what we call SPN token ID type. It's the entry. It's the entry in the ERC75Y storage of NFT collection. We can set its value to either to one of these two possibilities. We can set it to a number. So that means that this is an NFT that can increment over time. We can set it as its type as a bytes 32. This means that then we can have a more different approach to represent each singular NFT. We can to represent them, for instance, as serial number, or we can describe each singular NFT as its own ERC75Y contract. This is really the most interesting part. So let's go through each option. The first type is if we have a token ID as a number. It's just a plain U256. You mint, you deploy your NFT contract, you mint NFTs, the token ID will just increment one after the other. The second type is what we call the byte 32, and we call that a hash value, or like for instance a serial number. This is a more custom representation. If you want to use something you can use this type, for instance, to describe like a unique ID for the token, an ID that can have meaning for your app or for your NFT collection. It can be like the ID of a QR code or as I say, a serial number, which can really be a unique identifier that can represent something else that has more meaning for your NFT collection. But what we can do, as I said, is that we have this also new feature of representing the token with an ERC75Y contract. And what also we enable with LSP 8 is that not only the NFT contract here has its own metadata that describe the NFT collection, but every single NFT has also its own metadata. So in the current standard, as we saw with the token URI, you have just a link to a JSON file that describe every single the whole NFT collection. But here we enable to have a token ID with a link to the metadata for every single NFT. And each NFT can be either an ERC75Y contract, if we want the NFT to be the metadata of a single NFT to be on chain, or we can have the metadata of this singular NFT off chain as a JSON file. So let's see a first example of the first option. We have the NFT contract, the contract that mints each NFT. We have every single NFT here listed, and we can specify in the ERC75Y contract for this entry, for instance, the first hash for LSP8 metadata JSON, and then the rest for the token ID, depending on which token ID you choose. We can use this to reference to the JSON file of a specific NFT. So let's imagine for the first NFT here that starts with J77, we will use in the ERC75Y storage the key that starts with this hash, padded with this 0, and then we will put the token ID, J77, P, etc., etc. And the value that we will retrieve is a JSON URL, and it's a link to a JSON file that describes the token ID. So you can literally have a custom metadata under a JSON file in a different location, whether IPFS or centralized or decentralized file system. And you can have the metadata for each of these token ID stored separately apart from the whole NFT collection. The second option, which is really more interesting, is that you can create each NFT has its own contract. So every time you have an NFT collection here, and every time that you mint an NFT, you had actually create and deploy a new NFT contract. And this you can do it by setting this entry inside the NFT contract. You do the same principle. You have if you have a metadata contract that is created for a token ID, you store the address of the NFT, the singular NFT contract that has been minted by this contract under this key. So you have this first hash padded with 0, and then you have the address of this specific NFT that comes after. And this will reference to every two different ERC75Y contract, and every single contract here represent the actual NFT. So this is a very new way that we have to represent this singular NFT. At the moment on LSP8, we are quite early stage in how we are developing it. We want to see and explore a bit more what we can do with it. But yeah, I really encourage you to have a look on the contract, and if you face things that you find difficult to do, to report it to us here on Discord, because we are really interested to get feedbacks on this area. So really, in summary, this is you have two metadata into the contract. You have the LSP4 metadata, the one that we saw previously. This is what represents the metadata of the digital asset. So whether it is a token or if it's an NFT, it really describes the actual digital asset. When it's an NFT, it's good for describing the NFT collection. So, for instance, for instance, let's imagine let's imagine with a practical example. Let's imagine if this contract is the contract that means CryptoPunk. This contract has metadata as a field linked to some metadata to a JSON file, and this JSON file describes the purpose of this NFT collection. For instance, this is an NFT collection that describes CryptoPunks with unique hair colors and haircuts, etc., etc. This describes the whole collection overall. And then you have individual metadata for each NFT. So, for instance, this one could be, this is the green cypherpunk, and this is the red dreadlock cypherpunk, and etc., etc. So this is the idea. You have, in summary, you have metadata for the collection, and you have metadata for every single NFT. So yeah, really encouraging you to try that out and to explore more around this digital asset. And now I'm gonna leave it to Yamen to go over different. We're gonna move now to a different field. So we have covered LSP 7 and 8, and now we're gonna cover two new LSP standards that revolves around how we track assets on a universal profile or an LSP 0. And I'm gonna leave the microphone to Yamen, who is going to explain you the first standard that you can use in your universal profile to track the assets that you have received. Yamen, I leave you the microphone.
Thank you, Jean. It's a great explanation of LSP7 and LSP8. So I'm going to start with the LSP5 received asset standard. We explained that problem yesterday that is similar to the problem that we're going to explain also today. So yesterday we talked about how the problem of not being aware of the token we own. And today we are going to talk about the problem of how we are knowing the tokens we own. So here we can see on MetaMask that we own, let's say if we have MetaMask, some tokens will show up and we will know that we own some tokens, some amount of these specific tokens. But the problem is with how we're knowing that we own these tokens, and it's like having MetaMask doing what's called chain pruning. So MetaMask will take all the historical transaction and listen to them with the help of a centralized service, which is Etherscan, which could be Etherscan. And based on these historical transaction, we will know what token we own. So the problem with this action is that first we're relying on a centralized service to know which token we own. And the second problem is that often MetaMask will not show all the token we own. It will show only the famous token that we use, that are like mostly used, and it will discard the other tokens. And you will need to know the address of the token you own from, and you need to import it manually in MetaMask. So in this way, you will not know which token you own. all the token you own. So that's why, so this is a figure from the article that Felix wrote, Felix, the DApp engineer in LUKSO, and it's explaining how it's explaining the chain pruning process. So I advise you to look at this article. So we came up with what we call the LSP5 received assets standard, and it's basically not a smart contract. It's a metadata standard where we standardize just a few keys. One of the keys is this one, and basically with this key we can store the addresses of the different assets we own. So in this way, each asset have a specific address, and in this array we should store all of these assets. In this way, a smart contract can read from our storage, from the ERC725Y storage, what assets we own. So it will be done in a decentralized way, and I will give the example of an LSP0 ERC725 account. So if someone wants to know which assets I own, he will go into my storage and make a call to get data with this key, with this specific key, and he will get a bunch of addresses. And if we parse these addresses, we will see that each address refers to a specific token. So this standard is not just related to the LSP0 ERC725 account or the universal profile. Any smart contract that implement the ERC725Y can implement this specific key and store all the addresses of the assets owned under this specific key. So since this standard is really important, like now currently in the blockchain space, we only have this hype about tokens and NFT, and we don't have like creativity. So that's why we created an LSP1 universal receiver delegate that work with the LSP5 received asset. So now when you send the token, if you have set the universal receiver delegate, it will directly remove the token that you have sent. If you have sent the full balance, it will remove this the address of the specific token from your storage, and it will set the address of the asset in the recipient smart contract. So in this way, we have like more decentralized transfer, and we can know which asset each universal profile owns. So this is really the example. So we just do a transfer through the key manager. The token contract will inform the universal receiver. The universal receiver will call the universal receiver delegate, and it's an implementation that we build. And this implementation will call the key manager. And through the key manager, the universal receiver delegate will set data. So it will set the data relative to this specific address. So here on the sender, if the sender transfer all the balance, it will remove the address of this specific assets from the storage. And this is the recipient. It will store the address of this specific asset inside the storage. In this way, we can know which asset each universal profile own, and it's also readable by smart contracts. So now we will go to LSP12 issued assets, and it's also a metadata standard, but I will let Jean explain you the rest of the standard. To you, Jean.
Okay, super. Thanks, Yemen. For explaining this the LSP5. So as Yemen explained, we have these two standards at LUKSO really around keeping track of assets, and we saw this great feature that LSP5 enables, in particular when we link it to the universal receiver and the function and universal receiver delegate. So we can have this universal receiver delegate that enables to keep track automatically, and we always get notified about it. And here, this is in particular great, this feature of how we can keep track for what is it's incoming. But in this case, we're in the position of the consumer. We are looking at the consumer perspective, an address that receive assets. So, for instance, if I send ERC20 tokens or an NFT to Yamen, how can he be notified? But how about if we look at the perspective the other way around? How about if Yamen created an NFT and send the NFT to me, and how can I really guarantee that this is Yamen who created this NFT? And we have what we called LSP12 issued assets. And we're going to reuse the example from before. We have an artifact from universalprofile.club. So in this screen, you can see that there is this list of 4 assets creator. And if you remember, it's the address that are stored under the LSP4 creator key in the contract storage of the artifact contract. But here's the question. Here there is 3, in this website, there is 3 address, 3 universal profile that use a universal profile as a branding, claiming that they are the issuer and the designer of the artifact contract. But how can I ensure that? How can I really ensure that this asset is authentic and it has been really issued by these addresses? And the way we do that is with this metadata key. And the idea is very simple, is that when you are a creator on the blockchain and you have a universal profile, let's imagine you issue an asset, you should register the asset that you have created under this key. And this way, you give yourself the proof to the other participant, to other users, that you are the actual creator. And this is how, here's how it works. Let's go through the flow of verifying for authenticity. You can find this flow on the docs as well. Let's look up at the data key of each of these universal profile. So if we query the data key LSP12 issue assets, we will obtain an array of probably assets, and we can look up in this array if it contains the address of an artifact contract. So let's go through the example as a whole flow. We have Dematerialize, who issued this artifact NFT, and the Dematerialize has a universal profile. So Dematerialize, as we have seen, we have shown, it creates and issue digital assets, things like very unique assets, really unique NFTs. So Dematerialize creates NFTs, it issue them, but now how can I guarantee that? How can I do the process the other way around? How can I guarantee that this contract that I'm looking for, if you don't look at the right side, how can I guarantee that this contract is authentic and has been actually issued by the Dematerialize? How can I ensure that's not fake? It comes from the actual issuer. And we can do that as follow. So we have the LSP4 creator array. We look at the address we go into the contract storage of the NFT, and we retrieve the list of addresses under this data key. And we can obtain a list of the addresses of the creator of the NFT. And if we can have already the first proof that it has been issued by the Dematerialize, because the LSP4 creator array contains the address of the Dematerialized universal profile. But this is probably not enough, because if I fake the NFT, I can write whatever I want. So how can I do the process the other way around as well? I do this double entry checking by also looking, I see, okay, there is the Dematerialized address on the list of LSP4 creator. Now I go into the Dematerialized universal profile and I read its LSP12 issued assets, and I will get an array of assets that he has created. And if I want to have a proof, I will obtain in the list of issued assets the address of the artifact NFT. So by doing this double checking, we are basically able to verify that an asset has been issued by the right issuer and that it's genuine. So this is the way we check that, and this is how the LSP12 issue assets help us to guarantee this authenticity. And if you are a universal profile and you create digital assets, whatever the universal profile represents, if you issue this asset to ensure for the user who will be buying and then transferring your NFTs, you have to ensure that when you list the assets that you have issued and deployed under this data key. And now now we have seen the topic of tracking assets. We saw that with LSP5 and LSP12. And now we're going to move to a new topic. So we have seen how we can use assets in a different way with LUKSO. We saw how we can keep track of them, and how we're going to look at how we can store them, which standard we can use to store this asset. And I'm going to let Yamen go through the next standard, the LSP9 Vault. He's going to explain you how we can use this standard to hold all these tokens and NFTs that we have presented. Yamen, I'll leave you the microphone.
Thank you, Jean. So before starting with the LSP9 Vault standard, we're going to just give a reminder of the LSP0 ERC725 account standard from yesterday. So yesterday we said that this ERC725 account, this account should be used to operate on the blockchain instead of using external owned account. So this ERC725 account is a combination between all of these components that we're seeing on the screen. So it's a combination of ERC725Y. With ERC725Y, we can store information in the contract. With ERC725X, we can interact with other addresses on the blockchain, as well as creating a smart contract. With ERC165, we can detect the interfaces that we support. And with ERC1271, we can do signature validation. And with LSP1 Universal Receiver, we can be informed about incoming and outgoing transaction, and we can react on them. So this ERC725 account should be used to operate on the blockchain and to represent our identity. So now we're going to see the LSP9 Vault, and it's almost the same, but the only difference is that this contract is not supporting ERC1271. And that's because the LSP0 ERC725 account, we said that it represents an identity, but the vault should act like a wallet, and the wallet should not be related to identity. That's why we removed the signature validation. But this wallet can interact with other addresses on the blockchain. We can store information to this wallet, and we can also be notified about the incoming assets, for example, and we can react on them. And also we can know which standard we support. So this LSP9 Vault should be used for only a few things, like storing the digital assets, storing tokens and NFT. And this contract, as a feature, it can be owned by an external owned account or a universal profile, and it can be customized because it implements the ERC725Y storage. So we're going to see how we can restrict a vault to adapt through the key manager in the next few slides. So we said also one use case, and it's for the brand. A vault could be useful for a brand in the future. So instead of a brand issuing one NFT and selling one NFT per transaction, they could sell one vault that is containing several fungible token and non-fungible token, and maybe it can also contain some native coins, and sell all of these tokens and NFT through just one transaction by transferring ownership of this vault. So this could be useful for brands. And also the LSP9 Vault is useful through making each dApp control each vault. So we know Jean explained yesterday that with the key manager, we can restrict each address to control a specific address that we specify inside the universal profile. So we can have a social media dApp controlling a specific vault, and another music dApp that's controlling another specific vault, and a gaming dApp. And each dApp could have this vault that have its own NFT and its own tokens. And each dApp can only change the metadata and control just one vault, not the other. So we're going to see an example of this protocol. Let's say you have a universal profiles and you have some NFT and tokens, and you see a protocol that tell you, I do tokens and NFT trading, and I will provide a high return on investment. So you need to try this, but also you don't want to risk your universal profile or the assets you own. That's why one thing that you could do is to deploy a vault. You can deploy a vault and allocate some tokens to this specific vault, the tokens that you are okay with losing them. And then you will allow this specific protocol to only talk with the Vault 1. So now this protocol will be able to interact with other smart contract or addresses through the Vault, and our tokens and NFT that are stored inside the universal profile and also the metadata is safe. So now if the protocol tried to act maliciously, he will not be able to steal our funds from the universal profile or even change our metadata. He will only be able to operate on these tokens and NFT that we allocated to this vault. So in this way, we can make each dApp talk to a specific vault and interact with other addresses, and we can have our funds safe and also our metadata. And now I will leave it to Jean to explain you how we can show the vaults that we own inside our storage. To you, Jean.
Okay, thanks a lot, Yamen, for explaining the LSP9 standard. So we have seen, Yamen, how we can use this vault to really encapsulate tokens and NFTs and to just enable application to operate only on this vault. But now what we can do is that what we want to do is that we also need a way, the same way that we have for the assets, to keep track of which vaults you own. You can imagine in the future that your universal profile has a lot of digital vault where it store like different assets for different, as Yamen showed, different dApps, different purpose. And the way we do that is that we need cases like, for instance, we have a vault for the tokens that we trade on DeFi or decentralized exchanges, or we can have a vault where we want to really keep our very personal and valuable NFTs, or like another vault just for tokens that we use for gaming, and another vault if we are like a creator and we create NFTs, another vault for NFTs that we create because we want to sell them on marketplaces. So we need to create this vault for its different purpose, and we need to keep track of them. And it's very simple. It's just with another metadata key called the LSP10 vault. And if you query the storage of a contract for this data key, you will retrieve a list of addresses, and each of these addresses is basically the blockchain vault that the universal profile is the owner of. So let's see a basic flow through an illustrated example. And let's reuse the dematerialize as an example. So you have the dematerialize here, we have a brand represented as a universal profile with its one founder, and the dematerialize is controlled by a key manager, but it also has a universal receiver delegate that is linked to it. And so in our standard implementation of a contract, in our standard implementation of LSP, the universal receiver delegate, we have two automation in place. We have the first automation we saw, it's how we keep track of the received assets. And the second automation is how we keep track of the vaults that we have received and we have created. So let's imagine we want the dematerialize to create a vault, because let's say the dematerialize is going to create a collection of NFT, and they're going to sell the whole NFT collection as a whole, the entire NFT collection, and they want to put this whole collection in a vault, and they're going to sell the whole vault in an auction. So the founder of the dematerialize, what they're going to do, they're going to create a payload, which is basically calling the execute function on the dematerialize, passing instructing the universal profile to deploy a contract, and passing the bytecode of the vault. And at this stage, the universal profile under the LSP10 vault, it has the number 0. So the main controller of the dematerialized universal profile, if there is the two main founder of the two main controller, they're going to craft this payload. They're going to send that to the key manager. And the key manager is going to check the permissions of the founder. Is going to say, okay, who is sending the transaction? It's the two main controller address. He's going to try to check what they are trying to do. He's going to read their permission, and because they have the permission set and they are the main controller, the main admin of the UP, it's going to allow, it's going to bypass. And then it's going to forward the payload to the universal profile. And what the universal profile is going to do is going to run the execute function from ERC75X. It's going to specify for the first parameter, the operation type, it's going to specify 1, the number 1 for create. The call is 0. 0 is for a standard contract call or an address call, standard message call, and 1 for create. And it's going to specify create. The true address will be the 0 address, because we are creating a contract. The value, if it wants to put vault at the first place, is going to add some value. And then the data field, the fourth parameter, is going to be the bytecode of the vault. So this way, it's going to deploy a vault contract on the network. So we can see from this stage how the universal profile create a contract, create and deploy a vault on its own. And then what's going to happen is that in the constructor of a vault, when the vault gets created in its constructor, there is a function called notify the vault receiver, and it's going to call back the universal profile. It's going to call back the universal receiver function of the UP, and the UP is going to delegate the function, as we saw the same thing for the LSP5 receive assets, to the universal receiver delegate. And the universal receiver delegate is going to know through the hooks that what we are trying to do is that the UP is creating a vault, and it's going to come back, it's going to craft another transaction. We run it through the key manager, because we saw that every interaction with a UP go through the key manager. It's going to say, okay, the UP has created a vault. The vault has notified me via the callback. We're going to set data on the UP storage for the entry LSP10 vault, and we're going to specify the address of the vault. So it's going to call back the key manager, and the key manager allows the universal receiver delegate to operate on the contract storage only, and then it's going to register the vault under the contract storage. And this way, we have a list of received vault that has increased under the contract storage, and the UP now has become the owner of the vault. And yeah, that's basically how we create a vault on the using a universal profile, and how vaults in our standard implementation of the universal receiver delegate are added into the LSP10 vault metadata standard. And so yeah, and we have reached the end of the presentation. And to conclude, we can basically say that we can also use LSP to create new form of digital assets. And the aim is basically to provide a safer and improve user experience. And we can then create, transfer, hold, and authenticate. We can use this new form of digital assets to create them, to transfer them, to hold them, and to authenticate them in a more safer way. And we can also use these LSPs standalone, but you will get a much more better user experience with Universal Profile. And if we recap from the picture that we have from yesterday of a plate, we can add all these metadata into the plate, and we can see that we have a vault here linked with the received vault, and then we have the issued and the received assets. And so this is the end of our presentation, and I hope you both all enjoyed our part 2 of the workshop, and we thank you very much, and we invite you to the upcoming workshop around ERC75JS and the LSP factory. Thank you.
All right, perfect. Thank you guys. Such an awesome presentation. Let's go over the questions that we have in the Q&A here. Let me see. Let me bring those up here. Okay, who can I DM with questions about hackathon tasks?
So it's good that if you can join the LUKSO Discord server, and we have some section about the hackathon. Also, we have some development channels. You can ask your question there, and we will try to respond as soon as possible.
Let's see. All right. Are there any layer 2 or layer 3 tokens for the ERC 725 standard?
I'm not sure that I understand this question. Jean, do you understand this question? Can you elaborate more about?
Yeah, I'm not sure neither to understand. Maybe if we want to
Yeah,
take the
maybe
microphone,
he can give more context about what he's talking about.
Yes, if you can just give more context in the Q&A here or in the message, or if you want to come on stage, you can raise your hand and I can bring you on stage as well.
I think what we can say as well is that the standards, all of the LSP standard, and including ERC75 standards, they can be used on they are EVM. They can be used in any EVM-based chain. So you can basically use these standards to create digital assets or profile or any ERC75-based contract on any layer 2 that is EVM based. I don't know if that answers the question. Or yeah, if you want to give more details, I'm happy to listen. Yeah.
All right, let's see. Okay, so are the NFT on the L14 shown on Universal Profile cloud.cloud LSP8 with metadata JSON or ERC725?
So the NFT that are showing on L14 are not LSP8. They are an old version of, I think it was called the LSP4 standard. So yeah, I guess they use, I don't know if they use ERC725 because they are quite old, but absolutely they are not LSP8. That's thing I am sure about.
Yeah, so most of the UP and the digital assets on universalprofile.cloud, they use the very legacy standard for right now, because at the time the standards were still a bit under development, but we are planning to have universalprofile.cloud work on L16, and yeah, and as far as I know, there might be a migration process. Yeah.
Okay, perfect. Let's see. All right, how does the search on Universal Profile Cloud work so fast?
That's a very good question, and I'm not able to answer, but I think on the next workshop, the backend workshop, the backend and tools, you can definitely ask the question to Hugo and, and Callum, who are under the universalprofile.cloud website. They will be able to explain, to answer your question properly, definitely.
Okay, thank you. Let's see, the next question, Leon asks, are there docs on how to deploy 725 contracts? Can I use Remix?
So there is some docs to deploy universal profiles, or what we call LSPs or ERC725 account, but using the LSP factory on the docs. So you need to use docs, but we're planning to add more guides on how to deploy this contract with some basic tool like Remix.
So yeah, you will see tomorrow in the next workshop, not tomorrow, sorry. That the LSP factory, what it does is that it deploys you. If by ERC725 you refer to the universal profile and the LSP0, the LSP factory does all the job under the hood of setting up the key manager. So it's a very convenient tool, but you can definitely deploy any ERC725 contract as you in the way that you want, really, with your favorite framework. If you want to do, you can also do it via Remix. You can connect your local hard hat console and VS Code on Remix. It's quite convenient. If you do that quite often, it's very easy to do. So you run a local Remix script on your VS Code, and then you can connect the Remix ID from the browser into your local host, and then it will load your whole project on Remix, and you can use it to then connect to L14 or L16 and deploy it directly from Remix. So it's really up to you. You can do everything manually from the script, or you can do that, for instance, this method via Remix and VS Code by connecting it locally, or you can. But yeah, if you want to do the whole universal profile setup, we highly recommend either to do via the browser extension, or to do with LSP factory if you want to do that low level. LSP factory will do everything under the hood for like universal profile. But yeah, any ERC725 contract, you can do it manually as well.
All right, perfect. Let's go back to that other questions. Let's see, there's some elaboration on it. This one, are there any layer 2 or layer 3 token for the ERC725 standard? So let's see here. Okay, so this is the elaboration. See if this helps.
Yeah, the native coin for LUKSO is LYX. Currently, we don't have a mainnet, we have a testnet. That's why we don't have like protocols like creating their own tokens. But once we have a mainnet, everyone can create any layer 2 token related to any protocol. If this answer makes sense.
Okay, perfect. If there's more elaborations on that, just go ahead and enter it in the Q&A. Next question, is it possible to create a new 725 token via function create of 725x?
So with the execute function on ERC725x, you can do several operation. The operation 1 and 2, it's create and create 2. Basically, with this operation, you can deploy any contract you want. So you can even deploy a new ERC725 smart contract from the actual ERC725 smart contract that you're using, or even you can deploy a contract or a token or an NFT from the ERC725 account that you are using.
Okay. Next question, when can LUKSO have a mainnet?
I guess you will need to ask this question for the network team.
All right. Let's see. Those were all of the questions that I see on here. Let me just check the chat just to make sure.
I can add maybe a final thing on the question around how to create the token from the ERC725 contract. I'm just resharing my screen. So basically what Yamen was explaining is that this execute function, if you specify operation 1 or 2 as the first parameter, You can either deploy a contract via create, or if you specify two, you can deploy via using the create2 opcode under the hood. So like the contract will use either create or create2 if you specify the operation type. The way you deploy a token is what the bytecode parameter of the execute function. You will pass the data parameter, the fourth parameter of the execute function. You will pass the contract bytecode. So when you make a call using an ERC-75 contract, the execute function, you specify call as an operation type. And the last field, the data field, you specify the function, the ABI encoding function call, when it's of the contract you want to interact with. So it's for contract call, it's ABI encoding function. For contract creation, the data field is the bytecode of a contract, and you add in the bytecode the argument of a constructor as well. Don't know if you want to add something around that, Yamen, but basically this is how you deploy the token. You pass the bytecode in the function field, and this is how you will deploy the contract, basically.
All right, thank you. I don't see any more questions in the Q&A, so I think we can go ahead and call this session complete. I do want to thank you, Jean and Yamen, for such a great second session here, such great information that you shared. And there's a couple more workshops coming up. There's one on Monday, the LUKSO Tools workshop, and then on Tuesday, there is Building Basic dApps on LUKSO. So we do invite you to join those workshops as well. We'll go ahead and announce them on Discord with the appropriate link to join on AirMeet as well. So keep an eye out for that. Thank you guys. Thank you everyone for joining. Have a great weekend, and we'll see you next week. Bye everyone.
Thank you. Have a great weekend.
Thank you everyone, and have a good weekend. Bye.